Hi everyone, my name is Irfan and welcome to another IGCSE math session. The topic we're going to talk about today is functions. As you all know, this topic is included in the syllabus for IGCSE math as well as additional math. However, for the additional math, there are some extra details that we will not cover it in this video. So function is relatively an easy topic. You will see in a minute why. The first thing that we're going to talk about is what is a function. So you can think of a function as a machine which there is an input, and in return, corresponding to that input, we will get an output from that machine. All right, let me define a function such as 2x minus 1. So what does this function really do is that for every x that it receives from us, it doubles it, right? That's what these two indicates, and then subtract 1 from it. So let me put the input, for example, 1. So my x is 1. What does this machine do? This is 2x minus 1. It takes 1, multiply it by 2, subtract 1 from it, and in return gives us 1. So my output is 1. But what happens if I key in number 3? So it takes 3, double it, and then subtract 1 from it, and gives us 5 in return, right? So this is a function that I've defined, and I can even give it a name. For example, function f. So this is how we show a function. You write the name, and in the bracket, you should put the input, or what we call a domain. So you shouldn't really concern yourself with the names, but what you need to know that this x is my input, and it could take any value as long as it is within the domain of the function, as long as it's defined. Let's continue. This function was taking the x, double it, and then subtract 1 at the end. So how do we read this? This is f of x is equal to 2x minus 1. So whatever we get in return is called the output, or the range. That's another name for it. If you hear that word somewhere, you know what it means. And the input is also called domain. Now, what happened here when I chose x to be 1? So f of 1, it means wherever you have x in the original function, you substitute that with 1. So f of 1 is equal to 1, which we have already calculated here. And how about f of negative 2? Well, same thing. Wherever you have x, you substitute with negative 2. And in return, I'm going to get negative 5, right? The answer is negative 5. Let me define another function such as g of x is equal to x squared plus 1. So what does this function do? It takes an input from you and then raise it to the power of 2, add 1 to it, and give you the answer. So if you choose x to be 0, so what is the answer? 0 raised to the power of 2 plus 1 is 1, and g of 2 would be 2 raised to the power of 2 plus 1, which is 5. But how about g of t? Can you take a moment and think about it? Well, it doesn't matter what this input is, guys. What matters is that what happens to it. So this x is just kind of a symbol, right? It symbolizes our input. So when you put t in it, what happens is that t again is raised to the power of 2, and 1 is added to it. So basically, wherever you have x in the function, you replace it with t. Then what happens to g of 2x? Well, if you recall function g of x, it takes something, raise it to the power of 2 and add 1 to it. So same thing here, what we're giving it is 2x, not x. So the whole thing, 2x is my input. It takes it, raise it to the power of 2, and then add 1 to it, which the final answer is 4x squared plus 1, right? When you expand this bracket, the index 2 belongs to 2 as well as x. This is something that you have learned already from the law of indices. So this is really important. Some students, they get confused here, like what's going on. Let me give you another example, like what happens to g of 2x minus 1. Well, the same thing. You have to treat this, everything inside the bracket, you treat it as the input, and do not forget up here, this was what basically the function g do to every input that you give it. So here the input is 2x minus 1, 2x minus 1 must be raised to the power of 2, and then 1 is subtracted from it. If you expand this, if you recall from the famous algebraic, the identity, right? A plus b, or plus minus raised to the power of 2. The first term raised to the power of 2, last term raised to the power of 2, and then the middle term is double of ab, and the sign, of course, it follows whatever sign which is between a and b. So here we have 2x raised to the power of 2 gives me 4x squared. 1 raised to the power of 2 is 1, and the term in the middle, it is double of this times this, which is 4x, and the sign is negative, so I put a negative here, and then minus 1, this guy right here, let's not forget that. So the final answer is 4x squared minus 4x, which if you want, you can factor out. So let's go further and talk about some special functions, which we call them composite functions. And it happens when you combine two functions together. So what's really happening here? Think about the two functions that I just introduced to you guys. F of x was 2x minus 1, and g of x was x squared plus 1. Now, you all know what is the answer for fx squared, right? All you have to do is substitute wherever you have x, you substitute it with x squared. So this whole thing is the input. So the answer is 2x squared minus 1. But what would happen if you substitute x squared plus 1? So same concept, this whole thing is your input, and you know this function f of x, what it does is that it takes an input from you, double it or multiply it by 2, and then subtract 1 from it. And what goes instead of x, right, here is x squared plus 1. So that would be x squared plus 1. And if you want to expand it, you can, you get 2x squared plus 2 minus 1, which leads to 2x squared plus 1. However, if you look here, x squared plus 1 is defined as a function g of x. So is it okay if I say, instead of this, I write f of g of x, right? So you can put the g of x in a bracket, but it's not really necessary. If the input of a function is another function, so you can either write it this way, like f of g of x. Some books, they wrote it as f o g x, or some books, they just write fg, right? And the last type is more common in IGCSE exam. We will go through some past year paper question and you will see. So all three of them, they represent the same thing. And the answer is same as above, 2x squared plus 1, right? Let's do a couple of more examples. I'm going to define another function such as h of x here. which is x minus 1 divided by 2. And if I ask you to find h of f of x or h of f, I'm going to use the last notation from now on. So what you're going to do, the f is 2x minus 1, and wherever you have x in h of x, you have to replace that with f of x, which is 2x minus 1, right? And the rest is same, minus 1 divided by 2. So here, what should I put? I should put 2x minus 1. And the final answer would be 2x minus 2 divided by 2, which you can factorize 2 out from the numerator, and they cancel out with the 2 in the denominator, and you have x minus 2 as the answer. Let's do something fun here. I found f of g of x. Let me find g of f of x and see what's the answer. Do I get the same thing? What do you think? Maybe you can pause the video and do it for yourself. Let's see what we get. So this time f of x is the input. So basically, guys, you have to work your way from inside and go outward, right? So we go in this direction. And then f of x is 2x minus 1. G of x, it takes anything that you give it, raise it to the power of 2, and add 1 to it. That's what g does, the function g. And now the input is 2x minus 1, right? And if you do that, again, I'm going to use the identity to expand this. You get 4x squared minus 4x plus 1, and there's a plus 1 at the end. So the answer is 4x squared minus 4x plus 2. You can factor out 2 if you want, but that's not necessarily. So as you can see, it is totally different from what we got up here. So a very important conclusion that we can make here is that if you switch these two functions, g goes instead of f and f goes instead of g, these two are not equal. So it matters that which one comes first when we're talking about composite functions, all right? And there is another topic that I must cover before we go to doing past year paper questions, is the inverse function. So how can we find the inverse function if a specific function is given to you? Let's talk about f of x again, because that's quite a simple function to work with. 2x minus 1, right? That was the function that I defined earlier. Now, if I ask you to explain to me in words that what f of x does, I think all of you can say that it takes an input, double it, and then subtract 1 from it. And if I ask you to undo that, so basically the function f takes something, double it, subtract 1 from it. And if I ask you to define a function that undo the effect of f of x, what would you say? What do you think the answer would be? Well, one possible way is to say that since this is subtracting, right, you might say, okay, we add 1 and then divide by 2, but some of you might say, no, we divide by 2 first and then add 1 at the end, right? I'm going to give you the answer in a minute. Guys, this goes back to the arithmetic operation, the priority, if you recall, which one has priority over the other? Is it addition and subtraction or multiplication and division? But don't worry, I'm going to give you the answer. Let me teach you how to find the inverse of any function. So usually functions are given in this format to you. What you need to do, the first step, is to get rid of this f of x and write it in this format. So instead of f of x, write y. So copy down the function as it is. And then the second step would be to switch x and y. So if I do that, x goes on the left-hand side and y goes on the right-hand side. So this is a very important step that you shouldn't forget. Just switch x and y, and then make y the subject of the equation. So if you want to make the y the subject of the equation, there are quite few ways you can do that. You can get rid of this -1, bring it to the other side, or you can say I add 1 to both sides, which leads to this, and then divide both sides by 2. And I'm going to keep y on the left. So both sides divided by 2. So this is the final answer. And since I introduced y into the equation, I have to get rid of it now. So I'm going to use the notation for inverse function. This is how we show the inverse function of f of x. It looks like a negative power, but it's not, guys. It's different. So this is the notation for inverse function, and it's equal to x plus 1 over 2. So this is the last step. Do not forget to convert it and use the inverse notation. Now let's see which one of you guys were correct. So if this is my x, I have to add 1 to it and then divide by 2. We cannot say I divided by 2 and then add 1 to it. That would be a different thing. Or you can also, if you say since this is a common denominator, these 2 belongs to both 1 and x. So this is another solution that you say divided by 2. So that would be the third group of students that might say divide by 2 and then add half to it. So this is also a possible solution here, but I don't think any of you could thought of that. So let's stick to this because that's not always the case. In this case, this is an exception, guys. However, this is the final answer. You have to add 1 to it and then divide by 2. So I would say the correct answer was this, right? And this was, before I give you a couple of examples, if I ask you to combine f with its inverse function, right? So basically this is the composite function of f with its inverse. What would you do? Well, the inverse is this guy right here. And you know what f does? It takes something, double it, and subtract 1 from it. But here I have to put the inverse function in as my input. So, and I have already calculated that. It's x plus 1 over 2. And if you continue, the 2 and 2 cancels out, and we have x plus 1 minus 1, which is x. Well, is it a coincidence that you get x? Well, let's find out. If you recall g of x, I'm going to write it here. I introduce it as x squared plus 1, right? And let's find the inverse function of g and then form the composite function and see if we can get the same thing. Maybe we're onto something here, guys. Let me erase this part. So what I'm gonna do is that I get rid of g of x and write y instead of that, x squared plus 1, and then I switch x and y, okay? Just switch them, and then now I have to make y the subject of the equation, which y squared would be equal to x minus 1, and then y equals to square root of x minus 1, right? And the last thing is the notation, don't forget that, is square root of x minus 1. So the answer here is square root of x minus 1. Now let me find out the composite function of g with its inverse function. G takes something, raise it to the power of 2, and then add 1 to it. But what is that thing here? It's the inverse of itself, which is square root of x minus 1. And if you do that, these 2 with this radical sign is gone, and we're left with x minus 1 plus 1, which is x. So it's not a coincidence, guys. We can conclude something that any function, if you combine it with its inverse, right? Let's say h with the inverse function of h, it's x. Any other functions that you want to come up with, the answer is always x. So this was a nice question as well. We talk about inverse function. So let's go through some of the past year paper questions, guys, before we end this session. So, okay, this is question 1. There are 3 functions defined for us right up here, f of x, g of x, and h of x. Work out the value of x when f of x is equal to negative half. So the value of f of x is given, meaning which x over 4 minus 3 is negative half, and we have to find out what is the x that gives us this negative half if we put it inside f of x. And this is just the algebraic manipulation. Add 3 to both sides, and you're gonna get x over 4 is equal to 3 minus half is 2.5, or 5 over 2. Basically, you get rid of 4, you can bring it up or multiply both sides by 4, which gives you 20 over 2, which is 10. So the answer is 10. In the next part, they're asking you to find the inverse of g. So g of x, so you can write g of x here, but use x and y. Okay, so this is the first thing you do. Change their place, x and y. You bring x here, y goes there, and then you have to make y the subject of the equation. X plus 7 equals to 6y, and I'm going to continue here. And y, all I have to do is divide both sides by 6, and this is the final answer. Don't stop there. Please use this notation as well. And then that's it. We're done. So this is the final answer. I believe there is a third part. Let me scroll down. Okay. Work out the value of x when h of x equals to f of 13. Okay, I have to replace x with 13 for f. This guy, the left hand side is 13 basically over 4 minus 3, because f of x is x over 4 minus 3, right? Now the input is 13, so I just replace x with 13. And on the left hand side, we have h of x, which is 2 raised to the power of x. And you're asked to find x. So this is an exponential equation, guys. As you can see, the unknown is in the power. So if you recall from the law of indices, you can solve this easily, but let me deal with the right hand side first. This is 4. This should be 13 minus 12, right? You multiply 3 by 4 and then divide it by 4. So you get 12 over 4, and the answer is 1 over 4. However, 1 over 4 is equal to, you can write it as 4 raised to the power of negative 1, right? This is the law of indices. You can bring it up and just change the sign of the power. And you know that 4 is 2 to the power of 2 already. And then we have another index outside, and you multiply these two powers, right? If you recall the law that if a number is raised to power and then again raised to another power, the new power is the product of those two powers, right? Same thing here is 2 raised to the power of negative 2. So the right hand side, instead of 1 over 4, I'm going to write 2 raised to the power of -2. So the bases on both sides are the same. I can conclude that the powers must be the same as well. So the final answer is -2. The next question, because this is also past year paper question, f of x is defined as x squared, g of x is defined as x minus 3 over 2. So this is quite easy question. I think everyone can answer that. You just have to replace x with -5. So the answer is -5 raised to the power of 2, which is 25, right? And g of f of x. So the input is x. My final answer should be in terms of x as well. So there is no numerical value here. And it's the same as, so instead of f of x, I put x squared. So these two are same, right? And wherever I have x in function g, I replace it with x squared. So this is x squared minus 3 over 2. And that's it. Yeah, that's the final answer. It only carries 1 mark. And then the inverse of g. So g of x is x minus 3 over 2. X minus 3 over 2. Please show your working. You have to show your working. So this is y. And then change the place of x and y. So this is y minus 3 over 2. Try to make the y the subject of the equation. You multiply both sides by 2. You get 2x equals to y minus 3. And then y is 2x plus 3. And I'm going to use the notation, the inverse of g. The answer is 2x plus 3. Okay, so let's move on to another question. A function is defined such as 5 minus 3x. So f of 6 is equal to 5 minus 3 times 6, right? And that would be 5 negative 18 equals to negative 13. And now the input is an expression that is x plus 2. Well, it's all right. Wherever you have x, you replace it with x plus 2, or basically with whatever that comes inside this bracket, right? And if you expand it, you get 5 minus 3x minus 6. The final answer is negative 3x minus 1, right? It carries only 1 mark. And lastly, f of x. So you're combining the two functions together. Don't confuse this with the inverse, because if you recall, I have derived it for you that the answer is always x. However, this is not, we're not combining the function with its inverse, we're combining it with itself. So 5, or if it confuses you, you can write this as f of. So instead of the second f, you put 5 minus 3x, right? And then 5 minus 3, instead of the x, you put the function itself again, 5 minus 3x. That's my input. And then if you expand this, you get 5 minus 15 plus 9x. And the final answer is 9x minus 10. And that's it. Okay. So as you can see, the questions are quite easy regarding the functions. So they want us to find the inverse. Y is 5 minus 3x. Change x and y, change their position. So this guy go there, and y goes on the right-hand side. And you have to make the y the subject of the equation. Divide everything by -3, and you get negative x minus 5 over 3. Or if you want to expand this, get rid of that negative, the answer is 5 minus x over 3. However, do not forget to use this notation. Okay, the inverse function of x is equal to 5 minus x over 3. Okay, and I think there is one more question. We have two functions. First, they ask us to find g of 3x. So wherever you have x in g, replace it with 3x. Don't forget to raise it to the power of 2, because that's what the function g does. The final answer is 9x squared. The inverse function of f, so f is 3x plus 5. If you switch x and y, this is okay, and y equals to x minus 5 over 3, and that's it. The final answer would be x minus 5 over 3, right? Find f of x, give your answer in its simplest form. So f of x is 3x plus 5, okay. F of 3x, this is how we can start if you want. 3, then instead of x, I replace this whole thing. So 3x plus 5. This is where the most of the students get confused. This is my input now, guys, not x. So f of x is 3x plus 5, right? So it means whatever you give it, it triple it and then add 5 to it. But now instead of x, I'm giving 3x plus 5 to it. Why? Because they ask me to combine f with itself, right? So the final answer should be 9x plus 15 plus 5, which is actually 9x plus 20, right? That's the final answer. So that's it. That was the last question. And I hope, guys, you enjoyed this video. Please stay safe. See you guys next time. Thank you very much.